Hello and welcome. In this video, we'll solve some problems on inverse trigonometric functions. We need to find the value of this function. So we have sine inverse of cos x, sine inverse of cos x, and cos inverse of sin x divided by tan inverse of cot x plus cot inverse of tan x. So here we can use the formula. We know that sine inverse of x plus, or we can take sine inverse of a plus cos inverse of a is equal to pi by 2. So I can write sine inverse of a equals pi by 2 minus cos inverse of a. So here we can take this as a and this as b. So what I can do here is similarly for cos inverse also I can write cos inverse of a equals pi by 2 minus sine inverse of a, and in the denominator we have tan inverse and cot inverse. So we know that tan inverse of a plus cot inverse of a is also pi by 2. From this I can write tan inverse of a equals pi by 2 minus cot inverse of a, and cot inverse of a equals pi by 2 minus tan inverse of a. So we'll use the same thing. In place of sine inverse of cos x, I can use pi by 2 minus cos inverse of a. A is cos x. I can write cos x. The idea is to cancel this cos inverse and cos. So here we cannot cancel sine inverse and cos. So I'm converting this to cos inverse and cos so that I can cancel plus this I can write pi by 2 minus cos inverse of x is pi by 2 minus sine inverse of a. So I'll write sine inverse sine a. This is a, which is sine x. So divided by here also I can write, in place of tan inverse of cot x, I can write pi by 2 minus tan inverse of, or pi by 2 minus tan inverse of x is pi by 2 minus cot inverse a. So this is cot inverse of cot x plus pi by 2 minus cot inverse of a is pi by 2 minus tan inverse of a. So this is tan inverse, and in place of a I should put this tan x. It's tan x. Now I can cancel cos inverse and cos, sine inverse and sine, cot inverse and cot, tan inverse of tan, and I'm left out with pi by 2 minus x plus pi by 2 minus x. The denominator also we have the same thing, pi by 2 minus x plus pi by 2 minus x, and we can cancel these two. So the answer is 1. Let's move on to the next problem. So we need to find the number of real solutions of this equation. The equation is tan inverse of square root of, I'll write this as x square plus x plus sine inverse of square root of x square plus x plus 1 equals pi by 2. So we know that cos inverse of x plus sine inverse of x is equal to pi by 2. So we have pi by 2 here, so we can use this, we can exploit this formula. So I have to convert this tan inverse into cos inverse. Let's see what happens. So I write a triangle out of it. Triangle. So this is actually tan inverse of square root of x square plus x divided by 1, I can write. So this is my opposite side and this is my adjacent side. So opposite side is square root of x square plus x and the adjacent is 1. So now the hypotenuse will be uh, square root of square of this is x square plus x plus square of 1 is 1. 1 square is 1. So this is my hypotenuse. So here what happens is, place of tan inverse, if I write cos inverse of, what is cos? Cos is adjacent is 1 divided by hypotenuse. Hypotenuse is x square plus x plus 1. So cos inverse of this plus sine inverse of square root of x square plus x plus 1 is equal to pi by 2. So we know that these two terms should be equal. So here this term and this term should be equal for this equation to satisfy. Cos inverse of x plus sin inverse of x pi by 2. So these should be equal. These two should be equal. So 1 by square root of x square plus x plus 1 should be equal to square root of x square plus x plus 1. So if I cross multiply, I'll get square root of, sorry, 1 is equal to square root of a into square root of a is a. So I'll get x square plus x plus 1 under square root whole square. So this implies it is 1 is equal to x square plus x plus 1. So I'll take 1 to the right side. So what happens is I get 0 equals x square plus x plus 1 minus 1. So 1 and minus 1 will cancel. So I left out with x square plus x is equal to 0. So I take x common, x plus 1 equals 0. So the solution is either x should be 0 or x should be minus 1. So there are actually two solutions. We can verify this. If you put x is equal to 0, what happens? If you put x is equal to 0 here, so this becomes tan inverse of 0 plus sine inverse of 1, which is tan inverse of 0 is 0, sine inverse of 1 is pi by 2. So this gets satisfied. If you put x is equal to minus 1 here, again you get tan inverse of minus 1 square is plus 1, minus 1 0. So tan inverse of 0 will get plus sine inverse of again you get minus 1 square is plus 1 minus 1. So plus 1 and minus 1 will cancel. So we left out the square root of 1. Square root of 1 is 1. So tan inverse of 0 is 0 and sine inverse of 1 is pi by 2. So solution is, there are two solutions, which is 0 and minus 1. Let's move on to the next problem. Okay, this is an interesting problem. So we have alpha less than or equal to 2 sine inverse of x plus cos inverse of x less than or equal to beta. We need to find the value of alpha and beta. So here I can write 2 sine inverse of x as sine inverse of x plus sine inverse of x plus cos inverse of x, because I know sine inverse of x plus cos inverse of x is pi by 2. So this is alpha less than or equal to sine inverse of x plus pi by 2 less than or equal to beta. So I can transfer, or I can remove this pi by 2 by adding minus pi by 2 to this equation. So alpha minus pi by 2 less than or equal to sine inverse of x plus pi by 2 and minus pi will go, and I'll get beta minus pi by 2. So we know that the range of sine inverse of x, is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. So I have to equate this value to minus pi by 2. So alpha minus pi by 2 should be equal to minus pi by 2, and this should be equated to this one. Beta minus pi by 2 should be equal to plus pi by 2. So now we can find the value of alpha and beta. So at what value of alpha this equation becomes minus pi by 2, it is 0. Or you can write alpha is equal to minus pi by 2 plus pi by 2. So alpha is 0 and beta is equal to pi by 2 plus pi by 2, which is pi 90 plus 90 is 180. So option D, alpha is 0, beta is pi. Let's move on to the next problem. Okay, we have sine inverse of x plus sine inverse of y equals pi by 2. So we know a formula where sine inverse of x plus cos inverse of x is pi by 2. So for this equation to satisfy, this should be equal to cos inverse of x. So sine inverse of y, if sine inverse of y, if sine inverse of y is equal to cos inverse of x, then this equation gets satisfied. So sine inverse of y, what I'll do is I'll convert this to cos inverse. What I can do is I can write the the triangle out of it. Sine inverse of y by 1 I'll write. So this is my opposite side, and this will be hypotenuse. This will be hypotenuse. So this is 1 and this is y. So this side will be square root of 1 minus y square. So sine inverse of y I can write as, if I turn it to cos inverse, this is adjacent by a hypotenuse. Adjacent is square root of 1 minus y square, and hypotenuse is 1 anyhow. This is equal to cos inverse of x. Now I can cancel cos inverse and cos inverse here. So x becomes square root of 1 minus y square. So what is asked? We need to find the value of x square. So if you square it, I'll get 1 minus y square. So option is A. Okay, let's solve this problem. Oh, we have cos of, we have the sine inverse 3 by 4, cos inverse 3 by 4. So I'll split this to two sine inverse as sine inverse of 3 by 4. I'll write it two times because we have 2 times sine inverse of 3 by 4. I'll write it separately as sine inverse of 3 by 4 plus sine inverse of 3 by 4 plus cos inverse of 3 by 4. But sine inverse of 3 by 4 plus cos inverse of 3 by 4 is pi by 2. So in this place, I'll write pi by 2, and this I'll write here, which is sine inverse of 3 by 4. So we know that cos of 90 plus theta, which is second quadrant, is minus sine theta. So I can write this as minus sine of sine inverse of 3 by 4. Now I can cancel sine and sine inverse. So this is equal to minus 3 by 4. Option A. Okay. So this problem is actually easy. It looks little complicated, but it is easy. So what we have to do here is, since we see 1 minus x square, we need to substitute. We need to put x is equal to sine theta here. So if I put x is equal to sine theta, what happens? If I put x is equal to sine theta in this equation, just by substitution it becomes very simple. So this becomes sine theta by root 2 plus 1 minus sine square theta divided by root 2 minus sine inverse of x. So this is equal to tan of sine inverse of I'll write this as, let me take this one. Let me take a bracket in a different color. I'll write this as 1 by root 2 sine theta plus 1 by root 2. This is 1 minus sine square theta is cos square theta under root. So if I remove the root, I'll get cos theta, and I'll close this bracket, minus sine inverse of x. So this, I can use the formula now again. So this is tan of sine inverse of this place I'll write as cos pi by 4, and this is sine theta, and here I write sine pi by 4 because we know that sine pi by 4 and cos pi by 4 is 1 by root 2. So this is cos theta minus sine inverse of x. So now this I can write tan of sine inverse of, so this is sine A cos B plus cos A sine B. I can write this as sine of A plus B. Write this as sine of A plus B. Sine of, okay, I write it in the blue color only. So this is sine of A plus B is theta plus pi by 4, and this is minus sine inverse of x. So now I can cancel sine inverse and sine. So I'll get tan of theta plus pi by 4 minus sine inverse of x. But from this what I can, I have x is equal to sine theta, but we need to know the value of theta. So sine inverse of x is equal to theta. Theta is sine inverse of x. So I can cancel these two. So I'll get tan of theta is sine inverse of x plus pi by 4 minus sine inverse of x. I can cancel sine inverse and minus sine inverse. So I'm left out with tan of pi by 4, which is 1. Tan pi by 4 is 1. Option A. Thanks for watching.